Okay, welcome back. We're going to take some time to talk about radicals and rational exponents now. When you think of radicals, think of roots and the radical symbol, which is this symbol here. Radicals and exponents are closely related, and their relationship can be defined in the following way. The nth root of a number a is equal to b, and conversely, b raised to the power of n is equal to a. And don't worry, we'll be taking a look at plenty of examples to get a better feel for this. There are a few conventions you'll come across when dealing with radicals. Two of the most common types of radicals are square roots and cube roots. Square roots are denoted by a 2 for the value of n, whereas cube roots are denoted by a value of 3 for the value of n. Square roots can be written as follows, with 2 above the radical sign. Square roots are a special case in that if you see a radical sign without any number for the value of n, then square root is implied. Here are a few examples of square roots. The second, or square root, of 16 can also be written as such, again just with a radical symbol, with the number inside. Because the square root of a number signifies a number that can be multiplied together to equal what's underneath the radical, the solution to this problem can be written as plus or minus 4. And simply put, that's because 4 times 4 is equal to 16, positive 16, but so is negative 4 times negative 4. Because you're multiplying a negative times a negative, you get a positive. In a similar manner, the square root of 9 can be written with just a radical sign and 9 underneath that, and the answer will be plus or minus 3, again because positive 3 times positive 3 is 9, but so is negative 3 times negative 3. And again, the square root of 25 can be written as follows, with an answer of plus or minus 5. Things are a little bit different with cubed roots. With any root above square roots, that is, cubed root or the 4th, 5th, 6th, etc. root, you must always write the number above the radical sign to specify which root you're trying to solve for. For example here, the cubed root of 125 is positive 5. Unlike square roots, it's not negative 5, because here we're looking for a number that must be multiplied together by itself 3 times to equal the number that's underneath the radical. If you were to use negative 5 times negative 5 is positive 25, but if you multiply that again by negative 5, it's negative 125, so that doesn't work. A similar situation exists with the cube root of 216. The solution to this problem must be positive, otherwise you would get a negative 216 instead of a positive 216. And again, the cube root of 343 is 7 for the same reasons. As mentioned, when dealing with square roots, you can write the 2 above the radical, or you can write the radical symbol by itself. But a good way to memorize the lower roots is that when dealing with square roots, you can think of areas, and when dealing with cube roots, you can think of volume. When it comes to higher roots, however, use ordinal numbers. Ordinal numbers simply refer to numbers in order. So for example here, if there's a 4 above the radical, that will be referred to as the 4th root. As you count up, you continue in that manner. 5th root, 6th root, 15th root, etc. Okay, let's take a quick break. When we come back, we'll talk about properties of radicals, which are similar to the properties of exponents.